Thanks, Kate. Hopefully my voice is also, you can hear me?
Yes.
Great. So hello everyone, also from my behalf. I'm Mikko Kärnä Leino, also senior antenna engineer here in Radientum, and yeah, I will talk briefly about UWB antennas in automotive applications. So UWB stands for ultra wideband antennas, and yeah, how they are used in automotive applications. Mainly, it's the UWB is quite emerging technology in automotive at the moment, and one of the key areas where it is used is radar functionality. One of the main use cases for UWB is live detection in radar, and yeah, the UWB radars they work at let's say comparatively low frequencies, around 6 to 8 gigahertz frequency range, low frequency compared to the millimeter waves that Kate are going to discuss a bit later. But yeah, the why for example UWB, why they are good for live detection, for example, inside the car, is that compared to the millimeter waves, the UWB radars and sensors, they can penetrate through some material that are inside the car, for example, the car seats, or even like baby blankets. The UWB radar can see below those. And yeah, this ability to penetrate hard surfaces means why UWB is quite good use for live detection inside the vehicle. And also because we are talking about wideband applications with the UWB and quite high frequencies as well, that enables to have quite highly precise readings, for example, in location, in range, in distance, and in velocity. The resolution comes quite well with the large wider bandwidth. And other applications also what we see UWB used for are then these comfort vehicle access, like for example with mobile phones using UWB frequencies, the car owner can open the car without the keys. They can keep the phones in their pockets or in their bags and enjoy secure remote parking with their smartphones. Yeah, and about the okay, now able to change the about the examples I'm showing today, where we have done these live detection sensor simulations inside the car. So we have in these simulations used now only one UWB sensor and placed it inside the car in 2 different locations, and we have also then 2 human models present within the car itself as well. Typically, you are going to have more UWB sensors in your systems, but for example, with the simulations, we can get the idea how many of those you actually need, and also what is then the best possible location. These simulations have been done using the hybrid solver, as Kate already explained how those work. And for example, now if we look about the results we are getting, so for example, when we have the sensor behind the back seat, here you can see the electric fields radiating when there are humans inside and when they are not inside. So a bit different. Different responses. Oops. Sorry for skipping a bit ahead. Then we also have the case when we have the sensor on the rooftop. The fields are quite different, but well, and well, for these from these fields you can get kind of the idea where you might get the reflections in the car, but well, as you see in these two simulations, the fields themselves are not they give you the idea how the sensors are radiating within the car, but are those the best possible locations for them? Just looking through the electric fields, it's not very useful. And if you use this unidirectional simulation, so simulating only once, so that your source here, the UWB sensor, illuminates your target space, so inside of a car in this example, you can quickly then get, for example, the idea how different people are seen within the car. So in the picture here in the graph, I'm showing how different sensors, how they see the different people, and and we have recorded the losses with those persons. So higher losses, that means that we are seeing that person slightly better than other ones. And from these results, we can see that when the sensor is on the back seat, we are having higher losses within the persons. That means that we are seeing them better, and compared to the sensor on the rooftop, we are getting slightly worse response, meaning that okay, it seems that the sensor location on the roof is not the best possible in this case. And also, as understandable, the human on the back seat is in both cases seen better than the one on the front seat, because they are located more close to the sensor. But this is with the bidirectional, with the unidirectional solver. Then with the bidirectional simulation, we can also get the where that comes to useful is then to get the signal back to the sensor. Here we have done well, quite quick simulation, just showing how it might be done. So the sensor on the roof is illuminating the in the insides of the car, and we have done some post-processing with our simulation results, and with those results we can see that quite well the person on the back seat can be seen within the car, and how they are causing the strongest reflection here, so that when they are not present in the back seat, we are not seeing a response there. And quite okay with the bidirectional solver. We can also get the correct distance between the human and the sensor, so quite useful for detecting objects with the simulations. You can remove them from later on and see, for example, if they are causing like big reflections in your simulation model, but also to get the idea how your sensor might work in kind of correct environment. But yeah, that is shortly about the UWB sensors and how you can simulate them. And I'm going to now give the control back to Kate so she can continue with the millimeter waves.